Hi, everyone. This is Vishal Sharma. I'm a principal at Metanoia Inc. and the moderator of the Carry Ethernet group. And I'm delighted to come back to you today with another of our CE Live sessions. And as I've announced in the announcement on the group and at several other social media channels, I have with me today Neal Roche, who's CEO of Apposite Technologies, and Tom Naidu, my good friend and colleague, who many of you, of course, already know from various standards bodies and his work in the SD-WAN and software space. So I'm delighted to have both Neal and you, Tom. What I'd like to do is maybe start off by giving each of you an opportunity to talk a bit about sort of what current things you're really working on and how that relates to the SD-WAN space. So maybe, Neal, I'll give you a moment to introduce yourself, and then we'll go over to Tom.
Sure. Hi, everyone. My name is Neal Roche from Apposite Technologies. So we're a test and measurement company here in Los Angeles, and we've been making WAN emulation tools for about 12 years. And so it's just in the past couple of years that people have been taking our tools and applying them to SD-WAN for product development and also pre-deployment testing. So we've learned quite a bit in the last year about SD-WAN testing, and so I look forward to sharing that here today.
Wonderful. Tom?
Hey, thanks for having me. I'm Tom Naidu at Lucid Vision. I'm principal at Lucid Vision, doing consulting in various areas around open source software and SDN and networking. It's a whole big party of interesting stuff these days.
You've been involved deeply with some of the SDN software development projects over the years, Tom, right?
Yeah, I helped start and contributed to a lot of projects. Open Daylight, OPNIV. I'm currently kind of managing, running the ARIA Tosca project, which is a probably the most predominant Tosca compiler for the Apache project these days. And doing other stuff in the orchestration, SDN, NFV space, which is kind of the next challenge for the industry, making that work.
Great, well, wonderful, guys. So just a few topics of housekeeping for the audience and also for us before we kick off the main discussion. One is I had announced in the group and elsewhere that for questions, some of the attendees were kind enough to send me their questions, and I've included that in the list of things we are all going to cover. But if there is people watching and you'd like to post a question, there is a discussion in the group about a week back by Neal titled SD-WAN Test and Validation with Network Emulation Tools. And that's the one you want to go to. And there's already a lot of discussion, questions, etc. that are there. And please add your questions to that. I'll periodically be using that as a reference point, and I'll refresh my screen to see if new questions of any sort have been added. So that's the discussion you want to navigate to in the group. That's one central repository of anything related to this ongoing CE Live that we can keep for questions. So let me kick this off. I mean, obviously, the title is SD-WAN emulation, and how do we do it? But really, it begs the question, I guess, and we were talking earlier before we started about what SD-WAN is for the purposes of this discussion. So I think it'll be great if both Neal and Tom, you, as you were saying earlier, can kind of add your perspective on how you view SD-WAN as a technology, just so that we have the right context, because as we all know, there's a lot of ways to define SD-WAN, and anything and everything gets slapped with that label today. So that's the first thing. And then we'll go and talk about what it takes to emulate things and applications over SD-WAN. So Neal, maybe you can kick it off and sort of give us your perspective, and then we'll go over to Tom and see how we can put a box around this.
Sure. Well, one of the first things that we learned about SD-WAN was it allowed enterprises to supplement their private dedicated network services with consumer broadband connections, so they can have more bandwidth to each site at a lower cost, and provide kind of backup to users if one network goes down, that they have other network links. Also kind of promises to do some performance monitoring and optimize the transfer of different types of traffic. So you could maybe offload your less critical internet traffic to the broadband internet link and keep your business critical traffic on the the private dedicated service. So kind of that's how we understand the promise of SD-WAN. Tom, you want to add to that?
Yeah, yeah. I think it's interesting the whole resurgence of this kind of technology. I mean, as a lot of people know, we've had maybe 2/3 of the pieces that are part of the SD-WAN puzzle already in the past, right? I mean, we've had various VPN technologies, L3 VPN, MPLS, L3 VPN, L2 VPN, etc., VPLS, all that stuff, and then the other kind of third of the pie is the traditional WAN optimization technologies that were out there and seem to have come and go a couple of years ago, and there's a resurgence now in that space. And then combining those two things with some of the key tenets of that have emerged from the SDN kind of evolution in the networking space and software space, specifically things like logically centralized control and doing different overlay control, and leveraging all three of those things together, I think provides a consumer and a user with a very interesting service to use that's definitely or has the potential anyway to definitely be better, flexible, more flexible, cheaper to operate, cheaper to buy for consumers. So I think this is it's pretty cool time technology.
So both Tom and Neal, a question to you. In the current SD-WAN environment, then is it true that you still have an MPLS? I mean, of course, you have an MPLS service, but is it merely a connectivity service, or is it really a VPN of some sort that you're then sharing with the broadband link? I mean, what is the most typical configuration that you see out there in the marketplace?
Sure. Well, I just did a little screen share of a network diagram just so we can talk about something specific. So the typical scenario that we're seeing is that you'd have a dedicated service like MPLS in branch office and the main enterprise data center, and then a broadband link as backup, and also giving you more bandwidth, and then maybe even a third link like a 4G cellular data or satellite link, for redundancy. So this is the kind of scenario that we see. People want to kind of test this setup to see, well, if I'm installing an SD-WAN controller and I've got multiple links now between my remote offices and the data center, how will this behave under different conditions? Because one of the things about the SD-WAN controllers is they promise dynamic management based on performance. And so when you've got this dynamic management, there's the promise of what the data sheet says, and then you want to see how it really behaves on your network and with your setup, with your links. And so this is the kind of the typical scenario that we see.
Okay, cool. So Tom, you want to add something to that?
Yeah, actually, if you can, Neal, you can put your picture back up.
Oh, okay. Just
to add to that, so I've done a lot of work with a bunch of cable providers recently, and another tier one, and what's interesting is, and this is part of the advantage of this technology these days, is that the transport or the underlying network no longer has to be MPLS, for example. It can just be any tunneling mechanism, and that. And don't get me wrong, I love MPLS. I was part of that whole party, and that's a great technology that's actually still around today. But in terms of an access technology, it's very expensive relative to, what you can see today. I mean, you can see the different SD-WAN vendors, their CPEs are things that are, that are costing, at a retail price point of like $100. And so, you can see how that is in contrast to, 5 years ago. You go to a business grade telco offering, and they had to deploy, a $5,000 or $10,000 CPE. I mean, that's a significant difference in OpEx costs. But then you got to ask CapEx costs. But then you got to ask yourself about, all right, well, I've got a lot of extra moving parts here. How is it in terms of cost for managing and operating this setup? And that's where some of the newer SDN concepts come in, with the logically centralized control of this. In fact, that's one of the advantages to the SD-WAN solution, is that it's not it no longer falls under some of the hiccups that could occur in an operational network around traditional routing, routing loops and delays and things like that. And using tools like what Neal's company provides, you can form this feedback loop between the controller and the endpoints and the paths that are taken, to not only keep things resilient, but as Neal was saying, meet the SLA that the customer expects. And I think in a lot of ways, there's a lot of potential here anyway, to have a better customer experience.
Sure.
If this, if it's set up properly.
No, and then the other thing I want to throw in there is that, as you said, Tom, I mean, MPLS is a commonly used technology, but may not be the only one. And for us in the Carrier Ethernet group, I mean, even though we are way broader today in our discussions than just Carrier Ethernet, but I think various kinds of Carrier Ethernet solutions which don't depend on MPLS transport are equally good options, and in fact are being used to provide those cheap CPEs that you just spoke about, right?
Yeah, Carrier Ethernet is an interesting step in this whole evolution, right? You saw where we went from wild popularity of L3 VPN to then L2 VPN, this VPLS sort of era, and that was, a lot of that was driven by sort of Carrier Ethernet, Metro Ethernet, kind of deployments, right? The need for a simplified, cheaper, effectively CPE situation, and this is kind of just another step in that.
So Neal, in your work with customers, and you have a very wide variety of customers from different verticals. What do you find as the core technology? I mean, of course, MPLS, but what else are you seeing as options more commonly used by the folks you work with?
Well, a lot of what's driving our business now is the move to the cloud and data center consolidation. And so for us, it means more people are buying 10 gigabit links and multiple 10 gigabit links. And so they want to basically find out, okay, if I'm moving, these data center workloads over here 1,000 miles away, and I'm paying for plenty of bandwidth, and I'm buying multiple redundant links. How will these applications, these services run? So that's kind of the big driver for our business is people deploying multiple 10 gigabit links.
And then the technology on those links is just they're just 10 gigabit Ethernet, right?
10 gigabit Ethernet, yeah.
Exactly. So you're kind of eliminating the need for MPLS per se. I mean, because you're connecting to the data center and then out again from the data center to the customer locations.
And then the other thing people are worried about is the performance. You may have obviously line rate performance point to point on the Ethernet link,
Sure.
But if you have just a small amount of latency, 10 milliseconds, 30 milliseconds, they want to figure out, okay, everything worked together locally, right, in my data center. What is that delay now? What are these WAN impairments? If there's like a failover, let's say one link has an outage, even if it's for half a second, and there's a failover, my lights are going on and off here. Energy efficiency. So people want to know, like, what negative conditions can happen over this wide area, and then how will all the different systems behave. So at the network layer, application layer, find out, do they have the resilience to operate now 1,000 miles away?
Excellent, excellent. Well, great. So I think that is just about the right level of introduction that sets the context for what we spoke about earlier. So let me, the way I had structured this, Neal and Tom, is based on inputs from various attendees, as well as myself, and discussions and looking around the industry. I put together a set of questions that would kind of logically take us through the topic. And I think the most important thing to kick it off with is, first of all, to ask the question of, now, how do we even differentiate between emulation and simulation? Those are the two words that often get funged, they're fungible, and are they really? And what should one look at when thinking about the difference between them? So it'll be good because both of you, you come, Neal, of course, your company builds the product. Tom has a lot of experience in, doing software specifically for SDN and SD-WAN and so on. So it'd be great for us to hear your perspectives on what really is the key difference, and how does the software between the two differ, for example.
Okay, well, I can speak to that. People generally use the words interchangeably. So before we get religious or specific, people do use the words interchangeably, and even we do here, say simulation and emulation. But strictly speaking, how we define it is a simulation is more like a mathematical model. And so there's some famous simulation tools in the industry like UpNext and NS3, and so they're essentially building a theoretical model for their network design exercise. So that's the simulation, and then on the emulation, what we're doing with emulation is kind of replicating the real behavior of the network on the packets. So we're emulating the real network. So when a packet transits our emulator box, it's the impairments such as delay, loss, jitter, will actually affect the packets. So that's how we define emulation. Is it's the real effect or a realistic network effect.
So just a question. In the emulation case, are you doing like a packet by packet transition? I mean, are you basically looking at what would happen on a packet by packet basis? And then if that is the case, where does that packet trace come from, and how is that generated?
Okay, at the risk of oversimplifying our products, so our box kind of looks like a bump on the wire. So
okay.
So we can put an emulator in between any two network segments, and again, to simplify it, we're like a big buffer, right? So that we can insert delay and impairments on all the traffic or specific types of traffic, for example. So that's what a network emulator does.
But then for that purpose, you have to have a network in place already, or there can be two endpoints between which this box sits, where I'm not really in the live network or the actual network, but I'm able to run a trace through that.
Yeah. So frequently, how people set up and run a test network with our unit is they'll have one network segment simulating clients connected to our box, and then on the other side you have some servers, or you could use traffic generators as well. Typically, people are looking for at the the hardcore networkers will use for wire rate traffic generation, but a lot of IT folks they'll use iPerf, right? They just want to know with these network conditions, with this CPE that I've got on each end, or this routing configuration, what's my available bandwidth for this traffic type. And so they'll use tools, as I said, like iPerf, just to do throughput testing at the TCP level.
Sure. Sure. Tom?
Yeah, and I think there's a couple of other kind of perspectives around that too, right? One is like you're saying the sort of a priori testing of the situation, and that's how you figure out if this thing's going to work and scale and all that stuff. And then there's the active component, right? I mean, and that to me is like the part of the secret sauce of the SD-WAN solution, right? Is
Right.
that forms the feedback loop of the whole of the three components we just talked about. And doing that in the most unobtrusive way, I think, is important because obviously you don't want to overmeasure, but you also want to measure enough where you can you can pivot and make the right reaction, right? So if you're going to alter the paths or whatnot,
Right.
you got to be able to do that, right? So here's always
Yeah.
this is the chicken and egg thing, right?
Yeah. So I can kind of share with you how we do that, because I started off kind of explaining the simple emulation. Let's see. I think I'm sharing my screen now.
Got,
I started off, talking about if you think that you've got multiple WAN links essentially to one site. What we do with a network emulator then is we can emulate multiple links. So you just connect it to one port on the WAN emulator, and then we can emulate multiple links with different characteristics. And so normally what we do is we set up a baseline to represent, the typical characteristics of, say, a wireless 4G connection, a broadband internet connection, and then more like a dedicated high reliability service. And so you create, a profile there of what the fair or average performance characteristics are of those. And then to your point, Tom, then is we want to find out what's the dynamic in terms of the SD-WAN controllers. So what we can then do is insert some impairments dynamically in real time and monitor how the traffic is routed by the SD-WAN controller. So we could create, an outage event on one of those links. We could create, some temporary bursts of long delay. So instead of 60 milliseconds, it's peaking maybe to 200 milliseconds. And so the management of the SD-WAN, they should be monitoring the performance, and based on certain thresholds, they should say, oh, I'm now going to route that traffic instead of on the MPLS dedicated network over to my internet link, or if there was a link failure, over to my wireless link. So we can change those network impairments dynamically, just like the real world, and then monitor what's happening to the traffic.
so
Yeah, and that's important because that lets the operator in your figure. You still haven't shown there's an SD-WAN controller in there somewhere.
Yes.
So however that controller is getting the information you just talked about, it's then got to make a decision, right? And then it can do things like, some operators have, like for example, a business grade service, their CPE will have 2 exit points, and so on. And so then it's going to, invoke those changes, and then it's that how fast can those things happen, and what is the SLA, and so on. What is how are we doing? That's important, but that's how this is a really critical part of this solution, right?
So Neal, in the figure that you showed, and maybe it will be useful to put that figure up again if you don't mind.
Sure.
I saw that you had simulated the 2 endpoints, the data center. I'm sorry, the branch office and the data center. And what about the SaaS providers? I mean, is that also simulated, or I
Sure.
didn't see?
Sure. So what we can do on the WAN emulation side is we can apply different impairments to different traffic types. So if the traffic onto your SaaS provider, has a specific IP destination address or a VLAN or a subnet, we can then apply impairments to that traffic specific. So you can
The
selectively.
SaaS provider itself is not is that not simulated? I mean, the data center and the branch offices are simulated, but the SaaS provider connection is a real one, or that was really what I was trying to
Yeah,
understand.
sure, you can do that. So what customers sometimes do is they'll connect our box between their network access point and a real client and real SaaS provider, and
Ah,
look at what the service level is with different connection types. So if I've got let's say a business or finance application running from a SaaS provider, will it operate over a wireless link or this type of internet link? So we can simulate all different kinds of connections while connected to a real service.
Oh, I think we lost Vishal.
Oh, okay. Vishal, we can't hear you if.
Okay.
Okay, I guess.
Oh, his PC just rebooted.
Okay. Well,
okay,
we can
thanks.
keep chatting between ourselves, Tom.
Yeah, we can keep going through. I mean, we can go through the kind of the questions until Vishal gets back on. Yeah, I think one of where was the next one? We said we were talking about what factors complicate the testing, right? We were talking about some of that, right? I mean, I think one of the things that's interesting, kind of the takeoff of what you were just describing in that figure. Could you put that figure back up,
Sure,
please? So what's interesting, stuff I'm seeing in this space, a lot of people are talking about using, a lot of people like to run before they walk, unfortunately, and like they're talking about using multi-SaaS providers, right? So you have an Azure, AWS combination here, and then people are already talking about, well, I want to be able to flip a switch and jump from A to B, and in the configuration we have here, I mean, that's a lot of moving parts.
It is. It is.
Right.
And so
it's a changing set of moving parts too. Those SaaS providers that you can double click into that icon, and there's a lot of stuff going on in there, right?
Right. Yeah, I was recently at the VMworld, and I was looking at how they're talking about the software-defined data center being able to move workloads, and so a lot of people are looking at hybrid arrangements, right, where you've got some resources running in your own private data center, you have some in a private cloud, you have some on a public cloud, and you have some SaaS providers. So you've got this whole mixture. And so
there's also the question of, sorry to interrupt you, there was a delay. Go ahead.
Oh, and so the promise of the dynamic deployment of compute resources, it looks straightforward, because you can say, well, all these applications and services run on this type of server here locally, and I can replicate that with a push of a button now on AWS or whatever. What you're replicating, of course, is the compute or storage or memory. But you're not really replicating what the wide area network effects will be.
Yeah, exactly. And I mean, I think, and there's another question to ask here too, which might be a little provocative, but modern software architectures today are resilient enough to handle sort of a lot of these impairments. And so I've talked to a lot of people deploying a lot of larger software systems across this kind of thing. Mm-hmm. And in those scenarios, they actually don't care. I mean, to a degree, right? If the latency is rising or whatever, they've got compute nuggets, as I call them, like in your figure, in each one of those SaaS providers. And so, like just using like the Hadoop compute model, right? You could have 3 compute elements in there, and well, 2 of them will finish and one of them still doesn't come back, so I throw another one out to finish the work.
I agree that the modern software, built for the SaaS era, is resilient, and it is good. But what you find in a lot of big enterprises, right, is that they're moving tools,
They're
and
behind
services,
that. They're not
applications
using them yet. Exactly.
from the bank data center that's been running for 20 years, and
Correct. Yeah.
now they're moving those things around. And
So that's the question, right? I mean, so that's actually an interesting way to bubble this up, right? If you're thinking about these sort of performance issues and impairments, do you have an application architecture that withstands this stuff or not?
yeah, and so
You
a
use
lot of
old
people,
monolithic apps or something, for
yeah.
example.
So you're right. So a lot of our users they're, as I mentioned at the start, they're not just the kind of the network engineers. They're actually the IT groups who are moving these applications around, and they they feel they need to do this kind of pre-deployment testing.
Hmm. Yeah, for sure. I mean, the stuff that I've worked on, as recently as this summer with different operators in the space, it's like we've talked about, some of this tech is stuff people have seen before, right? But I think sorry, my energy savings are happening. The thing that these guys still have to do is a sizing and is this thing going to work in my current situation testing thing. So I think
Yeah.
doing, like, I call it pre-flight testing, right? But
Yes.
then there's, does it scale? Does it work right?
Yeah.
The last thing an operator wants to do is deploy a new service like this, and then in the first 6 months they have some massive outages.
Yeah.
So that's imperative, right?
Yeah, and then as you said, the SaaS software might be resilient, but if they're maybe storage replication, they don't know how that's going to behave for disaster recovery and backup, and so there's always certain applications that might be more sensitive than others.
So one of the kind of the next kind of related question Vishal had on here is, what are some of the approaches people have used in the past for testing validation, and are those getting carried forward, or are things getting jettisoned? That was kind of like what I was just talking about.
Sure.
We've got a bunch of Lego blocks here that 2/3 of them I think people understand and grasp.
Yeah. So what people used in the past, of course, is they'd build out a test network. So there would be time essentially to turn up a reference network or a test network of actual links. That was kind of expensive and time consuming. In labs, the bigger companies, you used to see actually reels of fiber. They would have hundreds of miles of fiber.
That's how you get delay.
Some of the big labs to create delay. So that was another approach.
That's one way to do it.
Yeah, and then closer to WAN emulation tools, what we do, there has been some open source tools on the market, like Linux type tools, or SourceForge type tools, where you could try and build your own WAN emulator, and so people have used those for years as well. They don't really. Generally, the free tools are good if you're dealing with low data rates and you just want to insert a delay, and you don't really care if it's exactly 20 milliseconds. It might vary around a bit.
Yeah, line rate stuff often requires special hardware,
Yeah.
to actually do it. Yeah.
Yeah. So we for SD-WAN and other applications, we feel as a test vendor, of course, we're saying you get precision and you get repeatability, so you can compare things accurately, and you don't have big variation on your test bed. So they were the kind of historical approaches: the freeware, the reels of cable, the test networks. So they were the different approaches that people used.
Cool. I think we have Vishal back.
Yeah, can you guys hear me?
Yeah, hey,
Yes.
welcome back.
Okay, sorry about that. As I said at the beginning of the call, when you're live, anything can happen, and
Anything can happen,
so
right?
there it was. So Tom, I saw that you were sort of going through some of the questions. So I just missed the last one you asked. I kind of came in and caught what Neil was responding to. So if you can clue me in, then we can pick up from there.
Yeah, we were just, sort of reflecting on how the tools, used to work, and what approaches were used in the past and what can get carried forward. And a lot of it is kind of the same stuff, right? I mean, delay, jitter, et cetera, bandwidth testing, like Neil was saying. Although I think one of the interesting things too is that obviously the technology is advanced, and so things like what Neil's creating. I mean, I think it's a lot easier and cheaper for these guys to build like WAN emulation, but it's still it's still tricky for somebody to go out and build a thing like this that actually uh, works at scale and all that, right?
Yeah. So I
Without
don't
custom
know.
hardware and stuff.
So Neil, I don't know if you've addressed this already, and maybe Tom, both of you can talk to that. Is what aspects of testing and SD-WAN make this kind of emulation sort of more involved or interesting today? And maybe you've talked about some of that while I was gone, but that's always something that comes to my mind. Why
Yeah.
would somebody want to use this kind of an emulation framework in today's environment?
Yeah. So I think one of the reasons that people use our unit that can treat traffic in different ways is that there's a lot of traffic management schemes and algorithms from different vendors, and people want to know, have I configured it correctly? Is it treating traffic in different ways? So, for example, I mentioned you can prioritize or route traffic differently based on the application type over an SD-WAN network. And so we can replicate the different connections with the different conditions, and then you can validate if your low priority traffic is routed over the secondary or tertiary links, and does your high priority traffic over the dedicated circuit. And then if there's a network impairments or delays on the dedicated circuit, how fast does it switch over? When there's other features such as they're sometimes binding multiple links for high bandwidth applications. And so if you're routing traffic across different links, there's other kind of hazards, right, in networking, which is misordering of packets, fragmentation. And so by doing some pre-deployment testing, you can make sure that any kind of traffic management aspect of SD-WAN is working as you expect.
So that actually is a good point. So that also addresses one of the thoughts I had, which is what kind of benchmarks are people keeping in mind? So the kind of benchmarks I assume they keep in mind are related to these impairments and these parameters, and then but for each application or set of applications, you will have some kind of performance benchmarks that you want these parameters to satisfy, and that can be verified, I guess, using the emulation tool, because then you insert an impairment, you see how it performs, and based on that, you can now judge whether you're likely to meet the requirements of this specific application that is running over the SD-WAN infrastructure, right?
And it's interesting too, I think, to bring up here is that those requirements differ, right? Whether it's retail, consumer, business, or or what they're going over, right? I mean, in Neal's original picture, he had some access technologies that were wireless, for example, right? And get you into the whole 5G thing. But even before that, right? I mean, I am working with an operator now that's a wireless operator that's trying to deploy SD-WAN over LTE, for customers. And so one of the things we haven't brought up is mobility, and the mobility as a key to this technology. We keep focusing on this sort of enterprise kind of view of this thing, where you've you're in an office and you've got some CPE thing and and all that, but you can imagine, remote workers, home workers, taking that $100 CPE, which most of them are a tiny little box, and going on the road with it somehow. So this is also why the performance monitoring is important. One of the things that you're going to find in SD-WAN is that people are going to be using different access networks to get to the SD-WAN. The closed user group, as it's called, right? So you could have one user on Comcast, one on Time Warner, one on AT&T, one in Europe on Orange or something, and measuring all of these things, these KPIs we've been talking about here is is not only important, but it's a challenge, right? Because it's, as you move, it's going to change.
Actually, that's an interesting point. So Neal, in your kind of deployments, do you see that mobility factor coming in, customers thinking about it, and to what degree do you see that in the kind of verticals you deal with, and is it more pronounced in certain verticals than others?
Yeah, I think our customers who are network architects are thinking about that, about how mobility is going to affect network performance, because it's going to be based on where things are in the network, so where resources are in the this hybrid cloud of different locations, and so people are thinking about that. I could actually share a really cool slide from a market research company called 451.
Sure.
So they just give these guys credit, because this is their material, 451 research, and so their latency is a really big deal on for Internet of Things and mobility, and so they're seeing that it's actually going to affect where resources in the network are placed, and ultimately, when you talk about 5G networks, they're actually talking about putting in micro data centers just to have lower latency, right?
Right. That's the whole sort of thought behind mobile edge computing, right?
Yeah, that's the MEC. I was going to say MEC. Yeah.
Yeah, and so what we think people want to find out is that the cost increases, of course, the closer you put compute at the edge, right? And versus a data center, which is in a low-cost location with low-cost energy, that's always going to be cheaper. And so, I think when people are looking at the network architecture, they're also looking at the cost of compute and the cost of that data center. And if your applications can handle the higher latency, then your cost is going to be lower, right?
Yeah, that's actually a big, a real kind of a sore point but an important one. When you see pictures like this, people go, "Oh yeah, of course, I can put a small, I can put a half rack in a node B area or something." But when you actually realize like where towers are and things, especially in large cities, real estate is expensive, power is expensive, all that stuff. So a lot of these things are just, they're not really possible in the cost envelope.
Right.
Yeah.
Right.
On that point, just last week I was at a meetup at LinkedIn, and the whole focus was on performance across the connectivity between the enterprise office and the data center, because that's how LinkedIn uses its resources. And one of the biggest things was exactly this, when they are trying to get rack space in a mobile operator's central office or this thing, they're like, okay, we can give you one rack. So they've talked about how they had kind of compressed their server technology and their technology for storage of content at the edge, and so that they could take up a very small amount of space in the operator's, you
Yeah.
know,
And it's not just a cost thing; it's a
central office.
physical space thing. I mean,
Exactly.
when
They
I
said
was
that they
working
physically
at
cannot give
BT,
you more
there were
space.
places in the city where there was a pop that was like as big as a Starbucks, a small one,
No, and they had to
that
do
didn't have,
they had to do a two-step operation where they put
yeah,
a routing device in the actual space in the central office of the operator, and then they actually put their content, the edge content hosting device in a different location so that they
in a
could
different
actually
location. Yeah.
make it happen.
Yeah, because people forget. I mean, if you get a pretty high powered server today, you get a 18 core Haswell whatever machine. These things have power supplies that are they're 1 kilowatt or more. You load up a rack of these guys, you're going to blow some fuses in these
Exactly.
little pops. So
Guys, based on what we were talking earlier, one of the things I had was, you know, different verticals can actually use this SD-WAN emulation idea, right? I mean, telcos themselves can use it, enterprises can use it, the system vendor guys, the Juniper, Cisco's, Brocades, etc., whoever, they can, use this. And Neil, I know in one of the slides you had government as an important customer, that is also, government organizations are using it. So one thing is, how does the use cases for different verticals differ? That might be, first of all, do they differ? And if they differ, what are the use cases that you find, maybe the couple of most important use cases for each of these verticals? What do they look like? Maybe, that'll be an interesting thing to talk about.
Sure. So I just threw up a picture there of our, some of our customer segments because we sell to big enterprise, we sell to the system developers, as well as the government and military, and so the big enterprise and government military, uh, they use this equipment to do sometimes vendor selection, as a first step. They want to understand how different vendors management approaches or performance monitoring, how they work. Does everything claimed on the data sheet actually, operate as it should? So vendor selection is kind of the first one, and kind of pre-deployment testing. And then we also sell to nearly every leading SD-WAN developer.
Sure.
And they use this, of course, for product validation, system testing in the lab to say, well, what if all these different negative events happen? 25 different types of impairment. How will our product behave? Will it be resilient and manage the traffic correctly? And then another vertical is the storage guys. So, the disaggregation of storage or storage over WAN is, the promise is to have your storage hosted now. It'll be lower cost and safer. And so companies want to find out, well, if I put this storage fabric in the at a colo facility, a managed service facility, how will it operate? And so we see a lot of people using WAN emulation to test storage for those applications.
Actually, that's an important point, right? I mean, I remember when we were talking offline, you mentioned that there's eventually you see a trade-off happening between latency and where you can put storage, right? And so that's a critical sort of thing to emulate, because you're going to make critical decisions about where.
But you got to know what the trade-off is going to be.
Exactly.
So that you got to know if does it make any sense cost-wise to put this thing there? If you're going to save 5 milliseconds and you're going to spend $5,000 a month extra, I don't know.
Yeah. So those are good, economic questions to see. Well, what's the trade-off in delay versus cost?
Exactly. And so I'm assuming that a lot of that is something that you're seeing customers using this for. And then a related issue is, we've been talking about emulation, and then there's emulation, and then there's reality, right? So when one implements a system after having emulated it, how far is that from reality, and how does then one?
How faithful is the emulation?
Yeah, precisely. How does one
Right,
go about
right.
bridging the gap?
Yeah, so great question. And I used to work for traffic generation companies like Spirent and Ixia, and it was always the question is, how realistic is your traffic generation or your emulation?
Sure.
And so for us, what we recommend is kind of chicken and egg. So we actually have a network profiling tool, which it's kind of like peeing on steroids. So what you could do is we can actually profile a live network link or multiple network links and record over time what the network characteristics are, loss, delay, etc., and then save that off as a little file and say, here's my profile of this network link, and then we can import it into the emulator and do like playback, and that could be 5 minutes repeating or 24 hours, etc. And so you can allocate the correct bandwidth, delay, and loss characteristics over time as a variation, because many of our customers, they want to emulate the busy periods during the day, right? The 8 a.m., 9 a.m. kind of stuff.
The worst case scenario.
Yeah, and so averages are not good. Right? They want to see the variation over time with bad periods, good periods.
And then one of the things I think we touched on this earlier, but let me come back to that, is we began to talk about 5G networks and IoT, and when we were talking about latency. So one of the things is, what are two related questions. One is, what are the latest trends that you guys are seeing in the usage of such emulation tools, and how can they be helpful for these emerging technologies that there's a lot of focus on in the industry today? So what do you see in that direction? Even if it's not happening today, what might you foresee they could be used for, and how might that evolve?
So
go ahead.
Yeah. So what we're thinking about doing to help people as the new, these newer technologies like 5G come along is we give you all the knobs to set things up yourself, but people want to know, well, what's this actual access network characteristics? And so something we'll probably do more is give people network templates to say, here's the typical average performance or poor performance of this access technology. So that's one answer in terms of having kind of templates to reflect different networks.
Tom, you have a thought on that?
Yeah, I think, well, I mean, the first thing I'd like to know is, like, what is 5G?
Yeah, that's amazing. That's a multi-billion-dollar question right there.
Yeah. So kind of to answer your original question, I don't know. I mean, exactly yet, but we know it'll be, faster rate of speed,
faster,
and all that stuff, right?
Whatever. Yeah, right.
But other than that, I don't know. But yeah, I think what Neal said is kind of what I was thinking. I think you don't know, and I think these solutions have to be flexible enough that they have enough knobs and buttons to let people customize for their environment. I mean, that's actually an important takeaway here, is that the SD-WAN deployments I've seen, and I've seen, I don't know, 5 or 6 active ones right now. None of them are the same, literally. I mean, and forget about the fact that they're using, most of them are different vendors, because there's 3 different vendors being used. But the actual deployment, architecture, philosophy, how are they doing CPEs, all that stuff is pretty different. And that's kind of an artifact of the provider that's doing it, right?
That's doing it, yeah. So actually, those are both critical points. So I just want to reemphasize that, which is that, Neal, you said that you're planning to give some kind of templates, which will essentially give some canonical performance benchmarks that people can work on depending on how the template applies to their kind of situation. And I think, Tom, you mentioned that as you've no particular SD-WAN sort of implementation is the same. So there will be this sort of tension between trying to derive the templates and then yet sort of servicing the needs of customers whose SD-WAN implementations might tend to look very different philosophically or implementation wise. So I think that's something that probably will continue for some time to come, right?
Yeah, probably for some time. I mean, if you look at the three main SD-WAN vendors, right? I mean, they're they're all very different. They use various kind of proprietary extensions or protocols for their internal routing. They use different CPEs. They do, I mean, there's already talk of doing SD-WAN controller interop kind of stuff,
absolutely.
right?
Yeah.
So I mean, it's there's a whole bunch of very big kind of areas of differences, right? So customization is a key here.
Get back to Neal and Tom, is there are a couple of questions that had come to me earlier, and I think this is a good time to address them because we've built up the background. So one of the things that somebody was interested in knowing, David Bass, one of my group members from the Carrier Ethernet group, is what can integrators do to learn about a product like Apposite's and help their customers in turn implement SD-WAN and so on. So that is something that might be worth maybe taking a couple minutes to talk about, because we talked about the different verticals that are using it, but I think an important glue piece in all of this, because of the wide variation, is going to be the integrator.
So the main message that in terms of what integrators can do is just kind of tell their customers that these tools exist and you can get a lot done in a short time. So my brother runs massive networks in Europe, and I was asking him about pre-deployment testing, and he says, "We don't do it. We don't have enough time." And so I think the key message for an integrator is to say to the customer, "Hey, it's worth investing a little bit of time to do some pre-deployment testing."
Sure, and I think people will. I mean, when you're doing the kind of expensive, implementation or that you are. I mean, for example, if you're putting stuff in a data center, you're building a data center, or buying space there, and you have these distributed locations, I think it behooves the enterprise or whoever is building that network to have that idea, because it's very expensive to find out post facto. I mean, we've always known that in networking for a very long period of time,
right.
But I think it's more important now to not discover things post facto, but rather have a sense beforehand, because the cost to if you're offering that as a service to a customer, or if you're using it yourself, the cost to not having the right performance can be pretty large.
And obviously, I think the responsibility is on us as a vendor, tools vendor, is that we need to make it really fast and really easy to do this type of testing. So you shouldn't need a training course essentially to run one of these boxes and to set up one of these tests. So speed and ease of use, I think, is on us. Like we need to make it easier for people to do this.
Actually, that's a very valid point, and we've seen that many years ago in the network planning tool space, where you had Wandle and OpNet and Caradan and various other players, and this was a key. This used to be a key point that how quickly can somebody out in the field or even a network architect set up the software and really start using it, because in many of them there used to be a huge learning curve, and you actually needed a significant amount of hardware to actually run the software itself. And that made it very complex. I mean,
well, that's what's cool about this tech, is that you don't need a lot of hardware for it to actually work. It's an overlay, and it's in fact, as we were saying in the mobility case, there may be no hardware you can test for in, if you're going, if you've got SD-WAN, like you're buying, say, Comcast SD-WAN, but you have some people that are off-net on Time Warner. Unless you've actually got a deal with Time Warner, you can go in there and test this stuff. You're going to have post facto issues, but but you should test for as much as you can here.
And then one more question that came up, Tom and Neal, was: do you guys have plans, Neal, particularly, to expand the offering inside the data center? So somebody was wondering whether we can test and emulate east-west traffic, for example, or is it already being done, or is that something that's on the anvil?
We are definitely doing that. So we will very soon we'll have a virtual version of our Netropy product that you can run on a VM in the data center. So you've got a virtual network emulation, and so that's coming soon. So
wonderful.
Yeah. So we're looking forward to allowing people to be able to turn up big network emulations on a virtual test bed, so you can see, okay, here's how the performance of the service runs now. How will it look to people, in New York or London or wherever, and so you can turn up links virtually.
And then just a related question: Do you see these emulation tools themselves being virtualized and put in the data center, or put in a
they have to be.
They can run?
They have to be, and
yeah,
if that's how our customers are building their test beds, our product has to be virtual as well.
So do you see a push in that direction at the present time, or coming soon? What are you seeing out there in the industry?
Yeah, people are asking for it. So when we go to these data center conferences, and they say, "I love your tool. Could you give me a software version? Because I know where to install it."
Everybody wants one. Yeah.
Yeah. Okay. Cool.
Yeah. The other thing I was going to say too is, and it kind of a related, but we haven't discussed area, is the actual SD-WAN control system. The software that's running the controller, right? I mean, that itself has its own, performance issues, accessibility, reachability issues, right? The nodes of the controller can't talk to the CPEs, we're going to have a problem. I mean, so that's something else that we need to add to this kind of testing conversation, right?
Actually, that's true. So is that something that the tool focuses on at this time, or?
We don't focus on the monitoring, performance monitoring aspect, but what we're planning to do is integrate, allow our product to be available through APIs, through the other kind of leading network monitoring and performance monitoring tools out there. So there's a load of great tools out there on the market for monitoring, the network now in this age of the data center and cloud. That can monitor from layer 2 to layer 7, right? And so we see our kind of partnering with those people so they can emulate and then monitor what's happening at every layer in the stack.
Cool. So let me just a couple things as we start to wrap up here is, one is, Neal, you have this white paper. So what I'd request you or Zach to do is, if you could provide everyone with a link, maybe just as a comment, where people can just go and download the white paper, that'd be fantastic, because that'll give people an opportunity to maybe read up more on some of the topics that we've talked about. And if there are questions, I will post that on the group as well, but I'm announcing it here so that the viewers and anybody else who sees it offline can come back to the discussion in the Carrier Ethernet group that I alluded to earlier, which is a discussion posted by Neal titled SD-WAN Test and Validation using Network Emulation Tools. And that's the one where people can pose further questions, because not everything gets resolved in one discussion.
Sure.
So we can continue the discussion there, and in addition to posting the white paper. And then before we kind of wrap up, we've talked a lot of things, but I do want to give both you and Tom, you and Neal, an opportunity to have any sort of last minute thoughts or point people in a direction where they want to know more. And then one thing I always like to ask is, because we have many among the audience are professionals that are maybe not working in SD-WAN as such right now, but are in allied areas. And it's always nice for people to know what they can do if they really want to dive into this space. This is not really related to emulation necessarily, but just that two of you are here. What advice would you give somebody who wants to sort of understand this space and maybe move into it professionally? Because that's a very important part of what people are coming to our group for, and what people are looking up to many of these CE Lives for.
Tom,
Neal, you want to go first? Yeah, I'll go.
Oh, okay.
All right. Yeah. The So you asked. There's two questions in here, right? So can you just give me a quick
Yeah, sure.
review of the first one? I was
Any
thinking
parting
about your
thoughts?
second one. Sorry.
Yeah, one was any parting thoughts on SD-WAN issues that we may not have covered. You already talked about that a
Yeah.
few minutes back, a couple of things, but anything else that comes to mind that people
Okay.
should be focus on? And the other was professionally, if they want to move
Yeah.
into this space, what
So
should
kind of
they?
related. So in terms of things we haven't talked about, I mentioned, sort of thinking about the controller infrastructure,
Sure.
thinking about, Neal mentioned a lot of the tools that are available. There are a lot of open source tools around this. There's, for example, open source projects related to this that are very related. For example, the ONAP, onap.org. They're working on orchestration, and orchestrating SD-WAN is definitely part of that purview. And then also blending in, making sure that performance monitoring is part of the solution somehow. Because I don't, all the vendors that are out there, they offer some sort of performance monitoring in their solution, but I'm not sure they're all created equal. And so considering the stuff that we've been talking about here, I think is critical to having a successful deployment. And then how can people get involved? I mentioned those organizations, and and thinking about that, because again, the technology that's here, 2/3 of it is basically stuff that we've known how to do for 10 years, but it's a sort of a mashup of these things plus some of the new concepts. So learning about the new concepts might be something useful for people too.
Neil, your thoughts?
Oh, well, I'd recommend people just download and read the white paper as a good synopsis of for evaluating SD-WAN. It's just like 5 pages, so it's a good quick read. And then the leading vendors are like Riverbed, Vitella, Silver Peak, people like that. They've obviously got good resources on their websites, and as Tom said, they have different approaches, and so schedule some pre-deployment testing if you're thinking about
They're not
deploying
all the
this.
same.
Yeah, they're
That's
all
for sure.
different.
Cool.
Okay, are you still there?
Did we lose Vishal again? Vishal, you muted?
Yeah,
I think
he
he
looks
probably
like he's
tried to
muted.
stop.
No.
Oh, there you go.
I'm not
You're back.
muted. I had to put a
Making sure
stop
you
to
didn't
some
crash
noise
there.
that was happening in the background, so that's why I excused
Oh, no
myself for
worries.
a minute. So great. So I think we've covered a lot of ground in this CE Live. So I just want to thank Neal, you and Tom, you for joining us here and giving so much valuable time and sharing the insights that you guys have developed on this topic. And as I said, we'll continue the discussion offline on the Carry Ethernet group, and we'll of course post the white paper, Neal, and have hopefully people will take a look at it and not only learn from it but come back with more questions. So that's what I want to do. And as always, at the end of every CE Live, I always tell people that may the bits in your bytes and the bytes in your packets be profitable. And then we'll see you next time. So thanks again, everybody.
Thanks. It was a
Michelle.
pleasure.
Thanks, Tom.